Well, hello, everybody. It's Thursday, April 2nd. Tomorrow is Friday, April 3rd. And then after that, you'll be on spring break for a week. So I'm sure all of you are looking forward to it. A lot of you have worked really hard the past 3 weeks in this online learning environment, and your brain really deserves a break. So I hope you enjoy your spring break next week. But before we get to spring break, we're going to do a little bit more work with quadratics and the quadratic formula. So what we've been learning about is how to use the quadratic formula to find the zeros of a function. And what we're going to do today is apply that knowledge to some different scenarios. So let's start with this first one, which says using h equals a negative 16t squared plus s, where h is the final height in feet, t is the time in seconds, and s is the starting height. Calculate how long it would take a ball to reach the ground if dropped from the top of the following structure. And we're going to round our answers to the 10th. So the world's tallest man-made structure is Burj Dubai in Dubai, United Arab Emirates, and its height is about 2,684 feet. So if we just start with this quadratic, okay, the quadratic is h, which is going to be the final height. And then we have negative 16t squared, which is our constant for gravity. And so anytime we're dealing with things in motion or moving objects that are going to be parabolic in their trajectory, we use that constant for gravity of a negative 16. So we have negative 16t squared plus s, which is going to be the starting point. Now, one thing you're going to notice that's a little bit differently here is I have an a term and I have a b term. I do not have a b term, but I have a c term. And the reason I don't have a b is because when we're dealing with moving objects, that middle term, the bx, always represents velocity, okay? That always represented velocity. So if this had velocity in it, it would be h equals a negative 16t squared plus, for example, 80t plus the starting point. This here always represents velocity, but there is no velocity because what we basically have here is gravity doing the work and pulling the object to the ground, okay? And that just basically looks like that, gravity pulling the object to the ground. So when we look at this and start putting in our values, the first thing it says is h represents the final height. Well, since the ball is going to fall to the ground, my final height is going to be 0, or ground 0, if you want to call it that. So I still have negative 16t squared, but s is going to be the starting point, or the starting height. So the ball is going to start up here and go down. So that's going to be 2,684 feet because it's at the top of the tower. So what we need to do now, like we've been doing, is use our quadratic formula to find the zeros of the function, and then that will tell us how long it's going to take the ball to travel from the top of the tower to ground 0. Okay? So let's go ahead and take the function that we wrote here. 0 equals negative 16t squared plus 2,684. All right, so that's the function that I wrote. So I'm going to use my quadratic formula to solve this function. So I'll start here with the negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. All right, so negative b, I don't need this time because I don't have a b value. So in this case, since the negative b is 0, we'll just not include it because that'll make our math a little bit easier. So whenever you don't have a b term, you can just not include it like I did there. But I still need to include the plus or minus. So I'm going to have plus or minus the square root of a negative 4. So then a is a negative 16. And then 2,684. all of that divided by 2 times a negative 16. Okay? So then I still have plus or minus because the square root can be positive or negative. That is the answer to it. So that would be 64 times 2,684. All of that divided by a negative 32. So when I do 64 times 2,684, I get an answer of plus or minus the square root of 171,776, and all of that divided by a negative 32. Okay? So what I'm going to do now is on my calculator, when I find the square root of 171,776, I'm going to have a positive answer and a negative answer because it's plus or minus the square root of that number. So when I find the square root of that and I round it to the 10th position, I have 414 and 1/10 divided by 32, and that's a negative 32. Then I also have a negative 414 and 1/10 divided by a negative 32. Okay? Because remember, I said my square root is plus or minus. So it's going to be positive and negative. All right. So what I do now then is when I divide 414.1 divided by a negative 32, I get a negative 12.93, which is going to round to a negative 12.9. And then when I do the same thing over here, I get a positive 12.93, which is again going to round to 12.9. So what that means over here is where it says calculate how long it would take a ball to reach the ground if dropped from the top of the structure. It would be 12.9 seconds. And so what that means is from here to here, if I thought of this as a coordinate plane, there's my axis of symmetry. And then I've got right over here 12.9. And then over here, I have 12.9 as well. Even though it's a negative 12.9, no matter where the ball falls from, it's going to still require 12.9 seconds to hit the ground. So there we found both the zeros for our function. Here is my maximum height. And then if I have here the axis of symmetry, I'm going to have the same measures on both sides because the axis of symmetry means a parabola is symmetric. All right, so that would be your answer there is 12.9 seconds. All right, so for those of you who feel comfortable, you can do the rest of the slides on your own. I'm going to do slides 2 and slides 3. So those who want to stay with me can stay with me. The rest of you are welcome to move on. And to do these yourself, make sure you show me your steps, show me success, and turn it in on Google Classroom. So let's move on to number 2 for those who want to move on with me. Okay, so for number 2, I start with the same function. All right, so it's going to be h equals the negative 16 t squared plus s, which is going to be my starting height. So again, I'm looking for the ball, how long it's going to take the ball to reach the ground. So that means the ball is going from here to here. So that's going to be ground 0. So how long does it take for it to go to 0? So that's going to equal a negative 16t squared because we keep our constant for gravity. And then my height this time, it says the next tallest man-made structure is the KVLY-TV mast in North Dakota, which stands at 2,063 feet. So that's going to be my function that I need to find the zeros for, which is going to tell me the answer to how long it takes the ball to travel from the top of the antenna down to the ground. All right, so again, we would start with our negative b plus or minus b squared minus 4ac over 2a. Now, since we don't have a b term again, because we're dealing with the negative 16t squared plus 2063, we'll just let b be 0. So we'll have plus or minus, again, the square root of 4, negative 4, times a negative 16, which is a, times 2063. All of that divided by 2 times a negative 16. All right. So again, we're going to have plus or minus. So negative 4 times 16, again, is going to be a positive 64. And then times 2063. All of that divided by negative 32. All right, so 64 times 2063 is going to give me plus or minus the square root of 132,032. So when I find the square root of 132,032, it's going to be plus or minus 363.4. That's rounded to the 10th. So I come down here and I do 363.4 divided by a negative 32. And then the 363.4 as a negative divided by negative 32. And when I do that math and round my answer to the 10th, I get a negative 11.4 here and a positive 11.4 there. Okay, so those are my zeros for the function. So that's where my parabola is going to touch the x-axis. So those are my x-intercepts. So this is going to be 11.4 seconds, which means from here to here is 11.4. And here to here would be 11.4, because this is my axis of symmetry. There's my maximum height. And since it's an axis of symmetry, it's going to be symmetrical on both sides of the parabola. All right, so let's move on to number 3. All right, so here's number 3. So again, we're using the same function. The h equals negative 16 squared t squared plus s. Okay. So again, we're looking for how long it would take the ball to reach the ground. So we're looking for ground 0. Now, it says the Sears Tower in Chicago, Illinois is a skyscraper that tops out at 1,730 feet. So my next value there is going to be 1,730. Okay? So that's what I'm going to come over here. And so, again, we would start with the negative b squared plus or minus, negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. So again, I don't have a b term, so when I plug everything in, I'm just going to have plus or minus the square root of a negative 4 times a negative 16, and then my c value is 1,740. All of that divided by 2 times a negative 16. So when I do 64 divided by 1,700 and is it 40 or 30? 30, that's what I thought. Okay, so when I do when I do 64 times 1,730, I'm going to end up with plus or minus the square root of 110,720 divided by negative 32. Okay, so when I find the square root here of this number, 110,720, I have plus or minus 332.7 divided by negative 32. So remember, that means I have 332.7 divided by negative 32, and I have 332.7, which is a negative. And so when I do all of this math, I end up with 10.39 seconds, which would round to 10.4. So I have a negative 10.4 seconds here, and then a positive 10.4 seconds here. So that means from the top of the tower down to ground zero, that's going to be 10.4 seconds. There's your other 10.4, because we said the plus or the minus, so the minus would be going the other way. But there again, we still have an axis of symmetry, which tells us that the parabola is symmetric or the same on each side. All right, so I'm going to sign off. If you need additional help, come up and see me on Google Meet. Other than that, have a great day and finish the rest of these and turn it in on Google Classroom.